Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating project, Wild, a very fast linker for Linux. It's generating quite a buzz. And for good reason.
A new linker? That's exciting. I've heard of Mold, which is already pretty speedy. What makes Wild different, and why is it needed?
That's a great question. Mold is indeed fast, but it doesn't currently support incremental linking. Wild aims to address that. The goal is blazing fast build times, especially crucial during iterative development. Think about how much time you spend recompiling during development. Wild aims to drastically reduce that.
So incremental linking is the key differentiator? But it's not implemented yet, right? What's the current state of the project?
Exactly. Incremental linking is the long-term goal. But even without it, Wild is already significantly faster than other linkers in many scenarios, especially for non-incremental linking. It's written in Rust, which is believed to make implementing incremental linking more manageable. Currently, it supports x86-64 Linux, and it's usable for development purposes. They've tested it with many popular crates on crates.io, and it seems to be working well.
Impressive. So how much faster are we talking? Do they have benchmarks?
Oh yeah, they do. Their benchmarks, run on a pretty standard system, show Wild significantly outperforming GNU LD, Gold, LLD, and even Mold, especially when linking without debug information. For example, linking Rustic driver without debug info, Wild clocked in at 486 milliseconds, compared to Mold's 946 milliseconds, and GNU Wild's whopping 20,774 milliseconds. That's a massive difference.
Wow, that's a huge speed up. But what about with debug info? Real-world development usually includes debugging, right?
You're absolutely right. With debug info, the performance advantage shrinks. While still faster than GNU LD and Gold, it's closer to Mold and LLD. The developers acknowledge this and are working on improving performance in this area. It's still early days for the project, remember.
I see. So it's not a perfect replacement for existing linkers yet, but it shows incredible promise. How easy is it to use?
Relatively straightforward. You can install pre-built binaries from their releases page, or build from source using Cargo. To use it as your default linker for Rust, you just need to add a few lines to your ~e/.cargo/config.tomtomstall file. It leverages Clang, so you'll need that installed.
And what about verifying that Wild is actually being used? How can you be sure?
Good point. You can use readelf to check the .comments section of your executable. It'll show you the linker version if Wild was used. Or, if you don't have readelf, a simpler method is using strings to grep for linker.
That's handy. So overall, Wild seems like a very promising project. It's fast, even in its current state, and the potential for incremental linking is huge. It's definitely worth keeping an eye on for developers who value fast build times.
Absolutely. It's a testament to the power of Rust and a great example of how open source innovation can significantly improve developer workflows. The project is actively developed, with contributions from several developers. Remember to check out the GitHub repository for more details and to contribute if you're interested. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a mind-blowing achievement, a WebAssembly compiler that's, get this, smaller than a tweet.
Whoa, seriously? A WebAssembly compiler that small? That's insane. What's the trick? Some kind of crazy bit manipulation magic?
It's a combination of clever coding techniques and a deep understanding of WebAssembly's inner workings. The initial version was 269 bytes, but they managed to shrink it down to a mere 192 bytes. It compiles arithmetic expressions written in reverse Polish notation, or RPN.
RPN? That's like super old school, right? Stack-based calculations?
Exactly. And the genius is that it directly generates the WebAssembly bytecode, bypassing any higher-level abstractions. Think of it as handcrafting the machine code, but for WebAssembly. No fancy libraries, just pure, efficient bytecode generation.
So it's basically writing the WebAssembly binary directly in JavaScript? That's intense. How did they even manage to make it readable, let alone functional?
That's the real story. The article walks through a step-by-step deobfuscation process. They started by simply formatting the code, making it slightly more digestible. Then, they tackled the assignment expressions, which were used to save bytes and reuse variables in clever ways. They replaced single-letter variables with more descriptive names, making the logic much clearer.
I see. So it's like peeling back the layers of an onion, revealing the core logic with each step. What other tricks did they use?
Oh, there were tons. They used sparse arrays to save bytes by representing zeros implicitly. They also exploited the fact that JavaScript's assignment operator is an expression, allowing them to chain assignments and avoid extra statements. They even used tagged template literals for string splitting, which is a pretty neat trick.
Amazing! It sounds like a masterclass in code optimization. Did they use any other particularly interesting techniques?
Absolutely. They cleverly handled arithmetic operations by using the index-of method on a string of operators, adding an offset to get the corresponding WebAssembly opcode. They also made assumptions about the size of numbers, using a 7-bit encoding which limits the range of numbers the compiler can handle.
So it's not exactly robust, but it's incredibly compact. A trade-off between size and functionality, I guess. What about the WebAssembly module itself? How's that structured?
The article breaks down the WebAssembly bytecode array, explaining each section: the magic number, version, type section, function section, export section, and code section. It's a detailed look at the low-level structure of a WebAssembly module. It's really fascinating to see how all the pieces fit together.
It's incredible how much they were able to pack into such a small amount of code. It's a testament to the power and efficiency of WebAssembly, and also a great example of clever programming techniques. This is definitely worth checking out for anyone interested in WebAssembly or code optimization.
Absolutely. And if you want to delve even deeper, the authors have a book, WebAssembly from the Ground Up, which promises a more in-depth exploration of the topic. It sounds like a fun read. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of tiny WebAssembly compilers. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into CS16.css, a CSS library inspired by the classic Counter-Strike 1.6 UI. It's amazing.
Wow, Counter-Strike 1.6? That's a blast from the past. So what makes this CSS library so special? Is it just a nostalgic throwback, or is there more to it?
Oh, it's much more than just nostalgia. It provides a complete set of pre-styled UI components, all emulating the look and feel of the iconic CS 1.6 interface. Think buttons, checkboxes, input fields, even sliders and dialog boxes, all styled consistently. It's incredibly easy to implement too.
Easy implementation? How easy are we talking? I'm picturing some complex setup process.
Nope, just a single tag in your HTML section. That's it. You grab the CSS from a CDN, and boom, you've got the whole library at your disposal. Seriously simple.
That's incredible. So what kind of components are we talking about? Are we limited to just buttons and basic stuff?
Not at all. We're talking a pretty comprehensive set. Buttons, of course, with disabled states handled elegantly. Checkboxes, input fields with labels, select drop-downs, even radio groups for those multiple-choice scenarios. There are also progress bars, tabs, and even a fully styled dialog box with a close button and a footer for actions. And, tooltips.
Tooltips? Now you're getting my attention. How does the tooltip implementation work? Is it flexible?
It's quite clever. You can position them on any side, top, bottom, left, or right, simply by adjusting the CSS within the tooltip element. It's not overly complex, but it's effective and customizable.
I see. And what about the styling itself? Does it truly capture the essence of the CS 1.6 UI? I'm a bit skeptical, sometimes these retro themes fall flat.
Oh, I understand your skepticism. But trust me on this one. The developer, Samuel, has done a fantastic job. The color palette, the fonts, the overall aesthetic, it's spot on. It's a really faithful recreation, but with a modern touch, making it usable in today's web development landscape.
That's reassuring. So, is it open source? And what's the licensing like?
Absolutely. It's released under the MIT license, so you're free to use it in both personal and commercial projects. It's all about community and sharing, which is great to see.
Fantastic. This sounds like a really useful and well-executed project. Thanks for highlighting it. I'm definitely going to check it out.
You're very welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll catch you next time with more exciting tech news. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating development in algorithm design, a near-perfect solution to the library sorting problem. It's not just about organizing bookshelves. It has huge implications for data storage and management.
Exactly, I'm buzzing about this. So this library sorting problem, or list labeling as the experts call it, is about minimizing the time it takes to add a new item, right? Like, if you have all your books crammed together, adding a new one is a nightmare. A real time waster.
Precisely. The classic approach, where everything shifts to make room, takes time proportional to n, the number of items. But researchers have been chasing a much better solution for decades. The 1981 paper set an upper bound of log n, 2, for average insertion time, using a deterministic and smooth algorithm. Smooth meaning evenly spaced items. Pretty clever, huh?
Log n, 2. So that's significantly faster than n, but not the ultimate dream. And the lower bound, the theoretical best-case scenario, is just log n, right? That's the holy grail.
Absolutely. The gap between log n, 2 and log n has been a major challenge. For smooth or deterministic algorithms, log n, 2 was proven to be the best you could do. But then things got interesting. Researchers realized that to beat log n, 2, they'd need to ditch smoothness and embrace randomness. A radical departure.
Wait, randomness? That sounds counterintuitive. Wouldn't that make things even messier? Like, imagine randomly placing books on a shelf. Chaos!
That's what many thought. But a 2022 paper introduced a history-independent, randomized, and non-smooth algorithm. It surprisingly reduced the upper bound to log n 1.5. The key was using history independence, which, ironically, is often used for privacy reasons. It's like cryptography for speed.
Wow, that's a huge leap. So history independence somehow helped optimize the sorting process? I see. Interesting.
Exactly. And last year, building on that, they got even closer to the lower bound, achieving log n, log n, 3. That's practically log n. They used a limited degree of history dependence, strategically predicting future additions based on past trends, but with a crucial element of randomness to avoid over-specialization. Brilliant.
So they're almost there, but there's still that tiny log n, 3 term separating them from perfection. Is it even worth chasing that last bit?
That's the million-dollar question. Some, like Seth Petty, believe the lower bound is correct, and any further improvement will come from lowering the upper bound. Others aren't so sure. The world's full of surprises, as they say. But even without that final piece, this is a monumental achievement. The practical implications for data structures and dynamic graphs are enormous. This is a game changer.
Absolutely. This research is not just theoretically exciting, it has real-world applications. Faster data processing, more efficient databases. It's amazing how a problem about bookshelves can lead to such significant advancements.
Indeed. And that's all the time we have for today's Tech Bytes and News. Thanks for joining us. And we'll see you next time for more exciting breakthroughs in the world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a truly impressive project, Snowdrop OS, a homebrew 16-bit operating system written entirely in x86 assembly language. It's amazing.
Yeah, I saw this. Completely from scratch? That's insane. What's the core functionality? I mean, what can it actually do?
Well, it's not just a kernel. It's a fully functional OS. It boots from floppy or CD, has a bootloader, a kernel that manages interrupts, and then loads a startup application. Think of it as a mini DOS, but way cooler because it's handcrafted.
Mini DOS is a good way to put it. So what kind of applications are we talking about? Is it just a command line interface, or is there more?
Oh, there's way more. We're talking a file manager, a text editor, graphical applications, even a basic interpreter and an x86 assembler and debugger, and of course, games. A Tetris clone called ASM-Tris, a snake game, even Minesweeper.
A Tetris clone? That's awesome! Did they write their own graphics libraries too?
Absolutely. The project includes a graphics and GUI framework, allowing for mouse-driven applications. They even have dynamic data structure libraries for linked lists, trees, and binary search trees. It's incredibly comprehensive.
Wow, that's a lot of low-level work. I'm impressed by the sheer scope. How did they manage to build all of this in assembly? Wasn't that incredibly time-consuming?
It definitely was a massive undertaking. But the result is a deep understanding of how operating systems work. The source code is publicly available, so you can see the incredible detail. It's a fantastic learning resource. The project evolved over many versions, adding features like multitasking, support for different devices like the PS/2 mouse, serial and parallel ports, even an LCD controller.
That's incredible. So it's not just a fun project, it's a valuable educational tool. I'm curious, what's the next step for Snowdrop OS? Any plans for future development?
That's a great question. The project seems to be complete, but the source code is open, so the community could potentially continue development. It's a testament to the power of assembly language and the dedication of the developer. It's truly inspiring.
Totally agree. It's a fantastic example of what's possible with a lot of hard work and a deep understanding of computer architecture. Thanks for sharing this. It's been fascinating.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating job posting for a founding engineer at Converge, a Y Combinator-backed startup. It's a seriously exciting opportunity, wouldn't you say?
Absolutely. A founding engineer role at a company already boasting over $1 million ARR, 180 plus customers, and processing billions in annualized sales? That's huge. Tell me more about what they do.
Converge is building a unified marketing measurement stack for online stores. Think of it as a single platform consolidating data collection, identity resolution, transformations, attribution, data forwarding, and analytics. They're vertically integrating the modern data stack, which is a really smart approach.
So essentially, they're providing a comprehensive solution for marketers to understand their customer journeys and optimize their campaigns? That's a massive market.
Exactly. And the best part? They're looking for a senior full-stack engineer with 6+ years of experience. They need someone productive and fast in React, comfortable with back-end development and databases, Python/Postgres preferred, and knowledgeable about deploying and scaling production software.
Sounds like a pretty demanding role, but the compensation package is certainly attractive. $160,000, $220,000 plus equity, 0.4% to 0.8%. That's a significant investment in the right candidate.
It is. And the perks are pretty sweet too. Private health insurance, pension contributions, and a 401k. But beyond the compensation, the company culture seems really appealing. They emphasize end-to-end product ownership, close customer relationships, and a bias for action.
I see. They value a proactive approach, continuous learning, and a positive attitude. That's refreshing to see. It's not just about technical skills, it's about the right mindset.
Precisely. They even mention a preference for simplicity in solutions, which I think is crucial in software engineering. Overly complex systems are often a sign of poor design.
I do have one slight reservation. While the requirements are clearly stated, the nice-to-haves, like prior experience with ClickHouse and deeper AWS knowledge, might unintentionally filter out some highly qualified candidates who could quickly learn these technologies.
That's a valid point. It's a bit of a double-edged sword. While those skills are beneficial, it might be worth considering whether they're absolutely essential for a founding engineer, especially given the emphasis on learning and growth.
Agreed. Perhaps a more flexible approach, focusing on the core skills and a demonstrable aptitude for learning, would attract a broader pool of top-tier talent. But overall, this looks like an incredible opportunity.
Absolutely. The interview process seems thorough, including a super day where candidates work on a real product feature. That's a great way to assess both technical skills and cultural fit. So listeners, if you're a senior full-stack engineer looking for a challenging and rewarding opportunity, check out Converge.
Definitely worth a look. Thanks for breaking down this exciting job posting.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Lightpanda, a headless browser designed for AI and automation. It's a game changer, folks.
A headless browser? Sounds intriguing. What makes Lightpanda stand out from the crowd, especially considering we already have heavyweights like Chrome and Firefox?
That's the beauty of it. Lightpanda prioritizes speed and efficiency. Think 11 times faster than Chrome, with a 9 times smaller memory footprint. That's a massive difference when you're dealing with large-scale AI or web scraping projects. Imagine running thousands of instances without crippling your server.
Wow, those are some impressive numbers. How do they achieve such performance? Is it some kind of black magic?
No magic, just smart engineering. They built it from the ground up using Zig, a low-level systems programming language known for its performance and memory safety. They also made some very deliberate design choices, like omitting the graphical rendering component entirely, focusing solely on what's needed for headless operation. It's all about optimization.
So it's essentially a stripped-down browser, focusing on the core functionalities needed for automation. But what about compatibility? Does it support JavaScript and common web APIs?
Absolutely. It supports JavaScript execution via V8, and they're actively working on broader web API support. It's currently a work in progress, but they're making great strides. They even have compatibility with Playwright and Puppeteer through the Chrome DevTools Protocol, CDP, which is huge for developers already using those tools.
That's excellent news for developers. But how easy is it to get started? Is it a complex setup?
Surprisingly straightforward. You can download pre-built binaries for Linux and macOS, making it easy to get up and running quickly. They also provide detailed instructions for building from source if you prefer, although that involves building several dependencies, including V8, which can be a time-consuming process. But the documentation is quite comprehensive.
I see. So it's a powerful tool, but still in beta. What are some of the limitations we should be aware of?
Right, it's important to remember it's still in beta. Expect some websites to fail or crash. The web API coverage is also not complete yet, but given the performance gains, it's definitely worth keeping an eye on and experimenting with.
Definitely. The performance gains alone make it a compelling alternative for certain use cases. It's exciting to see such innovative projects pushing the boundaries of what's possible in web automation. What about testing? How do they ensure quality?
They're using a combination of unit tests and web platform tests, WPT. They even have a dedicated repository for their WPT integration. This rigorous testing approach is crucial for ensuring reliability and compatibility.
That's reassuring. It sounds like Lightpanda is a promising project with a bright future. Thanks for shedding light on this exciting development.
My pleasure. And remember, listeners, you can find all the details, including the source code and documentation, on GitHub. Check out the link in the show notes. Until next time, goodbye from Tech Bytes and News.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Tilde, or TB, a new LLVM alternative. It's aiming to be faster and more maintainable than its predecessor. Exciting stuff!
Yeah, I saw this. The claim of a 2x faster preprocessor than Clang is pretty bold. What's the secret sauce?
Well, it's not just about speed. It's about a fundamental redesign. The author, Yasser, argues that LLVM, after 20 years, has accumulated too much cruft. He's essentially doing a redo, focusing on clean APIs and decoupled libraries. Think modularity, maintainability, and speed.
So a completely different architecture then. I'm curious about this sea of nodes IR. How does that differ from LLVM's SSACFG?
That's a key difference. Instead of the traditional static single assignment control flow graph, Tilde uses a sea of nodes. It's a different way of representing the intermediate representation, potentially leading to simpler optimizations and faster compilation. It's a bold choice, but potentially very effective.
Right. And the thread safety? That's a big deal for modern compilers, isn't it? Being able to compile multiple functions concurrently is a huge performance boost.
Absolutely. Tilde's thread-safe modules are a significant advantage. The ability to parallelize compilation tasks is a game-changer for large projects. It's a very modern approach.
The article mentions JITing and AOT compilation, but also direct executable output, bypassing the linker. That sounds radical.
It is. Bypassing the linker could significantly speed up the build process. It's still early work, but the potential performance gains are huge. It's a testament to the innovative approach.
The benchmarks shown are interesting. Comparing Tilde's optimized build to Clang's unoptimized build isn't exactly a fair comparison, is it? I mean, it's a bit misleading.
You're right to call that out. The author acknowledges it's not a fair comparison, but it does highlight the potential of Tilde even in less than ideal circumstances. It's a good point, though, and we should be cautious about interpreting those results too literally. The real test will be when both are optimized.
Definitely. But the project is integrating with Odin and Mini VM, which is pretty cool. Self-hosting by March 2024 is an ambitious goal, but achievable, I think.
It is ambitious, but the progress so far is impressive. The roadmap seems realistic, and the community involvement with Odin and Mini VM is a strong indicator of the project's potential. I'm excited to see how it develops.
Me too. This is a really interesting project that could shake up the compiler world. Thanks for breaking it down for us.
My pleasure. And remember, listeners, you can find links to the project, the author's contact information, and the benchmarks in the show notes. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating article on data branching for batch job systems. It's all about treating data like code, which is a pretty radical shift, isn't it? Exciting.
Absolutely. It's a game changer. The core idea is that we need to know not just the current data value, but its entire history, who changed it, when, and why. This is crucial for data security and debugging, right?
Precisely. Think about it. Rollback capabilities to any previous state, not just the last one. That's a huge leap forward in data management. And the audit trail? It's far richer than just a simple timestamp and user ID. We get the context of the change. Amazing!
So tools like LakeFS and Oxen.ai are essentially creating a Git for data, with branches, commits, and merges. Even PlanetScale is doing something similar with SQL databases. But how does this translate to batch job systems?
That's where the real magic happens. The article suggests using branches for different stages of a job. The main branch is your production data. Each job creates its own branch, allowing it to work on a copy without affecting the main branch. Safe and secure.
I see. So if the job succeeds, it merges its changes back into main. But what about failures or tests?
Excellent question. For tests, you can simply create a branch, run your tests on a copy of the production data, and then discard the branch. No risk to production data whatsoever. For experiments, you keep the branch around for longer-term analysis without merging it into the main branch. Clever!
And what about really complex jobs with multiple steps?
Ah, yes. For those, you can create branches for each step, allowing for parallel processing and independent commits. Each sub-operation gets its own staging area, making the whole process much more manageable. Then, once all steps are complete, you evaluate the results and decide whether to merge into the main branch. Ingenious!
It sounds almost like database transactions with ACID properties, but at a much larger scale. This is a really elegant solution to a complex problem, Bart. But, wouldn't managing all these branches become cumbersome?
That's a valid concern. However, the article points out that in LakeFS and Oxen.ai, creating branches is cheap because it doesn't involve copying the entire dataset. It's more like creating pointers, so the overhead is minimal. Efficient!
That makes a lot of sense. It's a really interesting approach to data management, offering a level of control and traceability that's previously been lacking. It's a significant step forward in data engineering.
Absolutely. The article concludes by inviting feedback and suggestions for more sophisticated patterns. It's a dynamic field, and this approach is likely to evolve further. But the core concept of treating data like code, with branching and version control, is here to stay. Revolutionary!
It's a fascinating concept, and I'm excited to see how this technology develops and impacts the field of data engineering. Thanks for this insightful discussion.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you found this discussion as enlightening as we did. Have a great day, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a truly remarkable project, the creation of a fully functional, open-source laptop from scratch. It's a story of incredible ingenuity and dedication. Amazing!
I've seen the video, and it's breathtaking. The sheer scope of this project is mind-boggling. So many components, so much custom design work. Where do we even begin?
Well, let's start with the core, the brain, if you will. The Rockchip RK3588 SoC. This isn't your average chip. It's a powerhouse, boasting quad-core A76 and A55 cores, a Mali G10 GPU, and even an NPU. Seriously impressive specs.
Right. And the choice of the CM3588 SoM was brilliant. It provided a solid foundation, readily available documentation, and minimized the complexities of high-speed signaling. Smart move, leveraging existing resources.
Absolutely. It's all about strategic choices. Then, there's the display. A stunning 4K AMOLED 13.3 panel. Talk about visual fidelity. Getting that to work with a non-mainline Linux kernel was a feat in itself, though. Reverse engineering ASUS laptop logs. That's dedication.
That sounds incredibly challenging. I can only imagine the debugging involved. And the powertrain? A 60 watt-hours Li-ion battery pack, meticulously designed with a charging IC, balancing IC, and power tracking. All custom built.
Precisely. The power calculations were crucial, ensuring safe charging and efficient power delivery. The ESP32S3 controller manages it all, feeding power telemetry over UART to the main system. Ingenious, but it wasn't without its challenges. There's still some work to be done on reducing quiescent current.
I see. And the peripherals. A custom mechanical keyboard with Cherry Mix ULP switches, a glass-topped multi-touch trackpad. The level of detail is astonishing. Even the keycaps were custom 3D- printed.
The keyboard is a masterpiece. The design is incredibly clever, using a thin battery and a custom PCB to keep the profile slim. And the trackpad, while using a readily available module, still required integration expertise. It's all about finding the right balance between custom design and off-the-shelf components.
The chassis is equally impressive. CNC machined aluminum. A minimalist design. But the hinge mechanism, using Framework's 13.3 hinge, was a smart choice, providing a solid foundation and readily available 3D models. Clever.
You're right. The thermal management was a significant hurdle, given the space constraints. A custom copper heatsink and heat pipe solution were necessary. It's a testament to the creator's skill that they managed to fit everything in such a compact space. The whole project is a masterclass in systems integration.
The software side is equally impressive. Using Joshua Reek's Ubuntu Rockchip kernel and leveraging the device tree for hardware configuration, it's a testament to the power of open-source tools and collaborative development. Brilliant.
Absolutely. The workflow, from DTS compilation to U-boot updates, is incredibly efficient. It's a beautiful example of how open-source tools can empower creators to achieve extraordinary things. This project is a true inspiration, showcasing the power of open-source hardware and software and the dedication of a single individual. It's a testament to human ingenuity and the thrill of creation, just as Tesla described it.
It truly is. A remarkable achievement. Thank you for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of open-source laptop creation.
Thanks for listening, everyone. Until next time, keep innovating. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating discussion about a clever hack involving QR codes. It's all about creating a single QR code that links to two different websites. depending on the angle from which it's scanned. Pretty cool, huh?
Whoa, that sounds amazing. So how does this even work? Is it some kind of optical illusion with the QR code itself?
Not exactly an illusion, more like a clever exploitation of how QR code readers work. Essentially, Christian Walther, the mastermind behind this, created a QR code where half the pixels come from one code and the other half from a second code. It's like a perfectly blended mosaic.
I see. So depending on the angle, the reader picks up more of one code than the other? That's brilliant.
Precisely. The key is that the mask, the pattern used to encode the data, is the same for both underlying QR codes. A slight shift in angle changes which half of the pixels the scanner prioritizes, leading to different results. It's incredibly ingenious.
So, what kind of results are we talking about? Different websites entirely?
Yep. In the original example, one angle led to a Mastodon profile, the other to a GitHub page. Guy Dupont, who initially proposed the idea of different perspectives on the same story, was blown away by the result. He even said it was 40 times cooler than his own attempt.
40 times cooler? That's saying something. But, doesn't this rely on the specific QR code reader? Wouldn't different apps or phone cameras behave differently?
That's a great point. And you're right, there's definitely variability. Some users reported different results depending on their phone's camera app or even the specific QR code reader they used. One person even got different results using Google Lens versus another barcode reader. It highlights the inherent inconsistencies in QR code scanning technology.
Interesting. So it's not a perfectly reliable method then? I mean, for a practical application, that could be a problem.
Absolutely. It's more of a proof of concept, a demonstration of what's possible. The reliability isn't guaranteed, but the ingenuity is undeniable. It sparked a lot of further experimentation, with people trying different masking techniques, dithering, and even color-based approaches. It's a fascinating rabbit hole.
It really is. I'm curious, what were some of the other approaches people tried? Did anyone improve on Walther's method?
Oh, definitely. One user, XSS Fox, experimented with dithering, a technique used to simulate more colors with a limited palette. They created a version that favored one code, but could still scan both by adjusting the angle. Another user, Nemo Thorx, even created a QR code with different codes embedded in each RGB channel. It's a whole new level of complexity.
Wow, this is getting really technical. It seems like there's a whole community of people exploring the limits of QR code technology now. It's amazing how a simple idea can lead to so much innovation.
Exactly. And it's not just about the technical aspects. The whole thing went viral on Hacker News, showing how a seemingly simple brain fart, as Walther himself called it, can capture the imagination of a large audience. It's a testament to the power of creative experimentation and the unexpected ways technology can surprise us. So, that's our quick look at this fascinating QR code hack. Thanks for joining us on Tech Bytes and News.
Thanks for the insightful discussion. Until next time.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating approach to leveraging LLMs for search relevance improvement. Even with their limitations, it's all about using classic machine learning to boost the performance of these dumb LLM judges. Exciting stuff.
I'm intrigued. So, the core idea is to use LLMs to make initial judgments on product relevance, right? But they're not perfect, hence the dumb label?
Precisely. The author uses an LLM to compare pairs of products based on various attributes like name, description, category, and classification in relation to a search query. Think of it as a series of simple yes/no questions the LLM answers. Each answer is a data point.
And these individual judgments aren't always reliable, I gather. So how do we get around that?
That's where the cleverness comes in. Instead of relying on a single LLM judgment, the author collects many of them, using different prompts and variations. Some prompts force a decision. Others allow the LLM to say neither or I don't know. Some even double-check the LLM's consistency by swapping the product order. It's a multifaceted approach.
So we're essentially creating a data set of LLM opinions, right? A lot of data.
Exactly. And this data set, combined with human-labeled relevance data, becomes the input for a classic machine learning model. A decision tree, in this case. The LLM judgments become features, and the human labels are the target variable. It's a beautiful blend of old and new techniques.
I see. So the decision tree learns to combine these individual, potentially unreliable LLM judgments into a more accurate overall assessment of relevance. A bit like an ensemble method, but more structured.
Exactly. And the beauty of this is that the decision tree provides interpretability. By examining the tree, the author can gain insights into which product attributes are most influential in determining relevance, according to the human judges. This helps guide search algorithm improvements.
That's really insightful. So instead of relying on expensive, large language models for the final decision, we use a simpler, more efficient model trained on the LLM's preliminary judgments. It's a cost-effective approach, too.
Absolutely. It's a fantastic example of how we can leverage the strengths of LLMs while mitigating their weaknesses. The author even explores different model types, considering gradient boosting as a potential alternative to decision trees. The possibilities are endless.
One thing I'm curious about, how robust are these results? The author mentions caveats about reproducibility and cross-validation. How much should we trust these findings?
That's a crucial point. The author rightly emphasizes that these results are a single data point, not a definitive solution. More testing and validation are needed to confirm the generalizability and reliability of this approach. It's a promising direction, but more research is required.
So it's a work in progress, but a very interesting one. It highlights the potential of combining LLMs with traditional ML techniques to solve complex problems in a cost-effective and interpretable way.
Precisely. It's a testament to the power of creative problem-solving and the enduring relevance of classic machine learning methods. This approach could revolutionize how we approach search relevance and other similar tasks. Thank you for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of LLM-powered search relevance. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the surprisingly crucial role of favicons in OSINT investigations. It's way more interesting than you might think.
I'm intrigued. I always thought favicons were just little website icons, a minor detail. What makes them so important for OSINT?
Precisely. That's the beauty of it. They're often overlooked, but favicons can be powerful indicators of malicious activity. Think about it. A phishing site trying to mimic Amazon will often borrow Amazon's favicon to appear legitimate. That's a huge clue.
So how do you actually use favicons in an investigation? Do you just look at them visually?
Oh no, it's much more sophisticated than that. We use their technical properties. You can find the favicons URL in the page source code, searching for things like file extensions, .ico, .png, etc. Size parameters like size of smiley face or the rel equals icon attribute. This gives us the direct link to the favicon image.
Okay, I see. And then what? You compare it to the legitimate site's favicon?
That's one approach, but we go further. We calculate the favicons hash value, a unique digital fingerprint. Tools like favicon, favicon grabber, favihash, and favicon hash make this easy. Then, we search those hashes on platforms like Shodan and Sensis to see which other websites share that same favicon.
Wow, that's like finding a digital trail using a tiny icon. So if a bunch of suspicious websites all share the same favicon hash as a legitimate site, that's a major red flag, right?
Exactly. It's a strong indicator of cloning or impersonation. The article gives a great example of finding fake Amazon sites in Russia by searching for a specific favicon hash. It's a quick way to identify potentially malicious websites.
That's incredibly clever. But what about the limitations? Are there any downsides to this technique?
Sure. One limitation is that some tools mentioned in the article are no longer functional. Also, a website could change its favicon, breaking the trail. And of course, a shared favicon doesn't automatically mean malicious intent. It could be a coincidence, though that's less likely.
Right, you'd need to corroborate the findings with other OSINT techniques. But still, it's a valuable tool in the arsenal. This is a really efficient way to find related websites, especially in large-scale investigations.
Absolutely. It's a fast, efficient way to identify potential connections between seemingly unrelated websites, and the tools are readily available, making it accessible to anyone interested in OSINT.
This has been a fascinating discussion. I never considered the power of such a small image. Thanks for shedding light on this often overlooked aspect of OSINT.
My pleasure. And remember, folks, even the smallest detail can be a crucial piece of the puzzle in OSINT investigations. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into David Bowen's fascinating telepresent wind installation. It's a truly unique piece, blending art, engineering, and a dash of the unexpected. Isn't it amazing?
Absolutely. I'm already intrigued. So what's the core concept behind this telepresent wind?
Essentially, it's a remote sensing and actuation system. Think of it like this. You have a single plant stalk outside, exposed to the elements. This stalk is connected to an accelerometer, which measures its movement in response to the wind.
Got it. So the wind's movement is being measured.
Exactly. That data is then transmitted, in real time, to a gallery space, where a whole array, 126 to be precise, of similar plant stalks are mounted on tiny, independently controlled tilting mechanisms.
Wow, 126. That's quite a setup. So the gallery stalks mimic the movement of the single outdoor stalk?
Precisely. They move in unison, mirroring the direction and intensity of the wind at the remote location. It's a real-time, physical representation of a distant environment. It's almost like the wind itself is teleported into the gallery.
That's incredibly clever. But what's the artistic significance? Is it just a technical marvel?
Oh, absolutely not. It's about the connection between remote locations, the subtle power of nature, and the translation of that power into a visually stunning and engaging experience. It blurs the lines between the natural and the artificial.
I see. So it's not just about showing the wind, but about the experience of the wind, translated across distances. It's almost poetic.
Exactly. And the scale is impressive. It was installed in Bilbao, Spain, with the sensor in Minnesota, halfway across the world. The wind in Minnesota was literally moving art in Spain.
That's mind-blowing. Did it work as intended? I mean, with such a distance, there must have been some challenges.
There were definitely technical hurdles. But the installation was a success. The system reliably relayed the data, creating a compelling and accurate representation of the wind's movement. It's a testament to Bowen's ingenuity.
It's fascinating how Bowen uses such simple elements, plant stalks, accelerometers, to create such a complex and thought-provoking piece. It really highlights the power of simple, elegant solutions.
Absolutely. And it's not just about the technology, it's about the artistic vision. Bowen's work often explores the intersection of nature and technology. And telepresent wind is a perfect example of that. It's a beautiful and powerful statement about our relationship with the environment.
I completely agree. It's a truly remarkable piece of art and engineering. Thanks for shedding light on this.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating approach to train routing, DIY routing, as implemented in the Tech Bytes app for Tokyo train schedules. It's a unique take on a common problem, and I'm excited to discuss it.
I'm equally intrigued. So, this isn't your typical GPS-based route planner, right? What makes DIY routing different?
Exactly. Instead of inputting your origin and destination and letting an algorithm figure it out, Tech Bytes DIY routing lets you, the user, build your route step by step. You select each train segment, specifying departure and arrival stations and times. It's all about empowering the user, especially those familiar with the Tokyo train system.
That sounds intense. Like for serious train nerds only? Haha.
Not necessarily. It's definitely geared towards power users who are comfortable navigating the Tokyo transit system. But the benefit is incredible precision and control. You're not relying on GPS estimations for walking times, which can be wildly inaccurate in Tokyo's dense urban environment, especially underground. Think about the frustration of an app telling you to walk 5 minutes when you're already on the platform.
Oh, I've definitely experienced that frustration. So, how does this DIY approach handle transfers? Is it a nightmare to coordinate?
Not at all. It's surprisingly intuitive. You add each segment, including transfers, and the app keeps track of everything. It even shows you alternate departure times for each segment, so you can easily adjust if you miss a train or want a slightly different schedule. It's all about flexibility and control.
That's clever. But what about the downsides? Surely there are limitations to this DIY method.
Absolutely. DIY routing isn't for everyone. If you're unfamiliar with the Tokyo train system, it'll be challenging. Also, it's not ideal for comparing multiple routes or planning trips far in advance. Ikibright currently only supports same-day planning.
I see. So it's a niche solution, but a powerful one for the right user. What about the app's design? How does it make this DIY process user-friendly?
The app's design is key. It uses a bottom toolbar that persistently displays your route as you build it. This makes it easy to add segments, see your schedule at a glance, and adjust on the fly. Plus, it integrates with the iPhone's dynamic island and lock screen for at-a-glance updates, even when the app isn't open.
That's a really smart use of the dynamic island. It sounds like a great solution for someone who knows the system well and wants precise control. But how do you teach people to use it? It's not exactly intuitive at first glance.
That's the million-dollar question. The author admits they haven't quite cracked the code on user onboarding yet. They're considering tooltips, interactive tutorials, and even video guides. It's a challenge to get users to embrace this different approach to route planning.
Definitely a challenge. But the potential is there. It's a refreshing alternative to the often clunky and inaccurate route planning we see in other apps. Thanks for breaking down this unique approach to train travel.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Magenta, NVIM, a seriously cool NeoVim plugin that leverages the power of LLMs for coding assistance. It's all about tool use-focused AI, folks.
Sounds exciting. So, what's the core idea behind Magenta, NVIM? Is it just another coding assistant?
It's more than just another assistant. It's a game changer. Instead of the plugin trying to cleverly manage context, Magenta, NVIM, lets the LLM agent itself decide what context it needs using tools. Think of it as giving your AI a toolbox, you know?
Interesting. So how does this toolbox work? What kind of tools are we talking about?
Well, it's got a bunch. Listing directories, getting file contents, accessing LSP diagnostics and references, even performing in-place edits with a review diff afterwards. All this is done through the LLM's interaction with the tools, not pre-programmed logic within the plugin itself.
That's a pretty powerful approach. But how does it compare to other similar plugins like Avante.nvim or Code Companion, NVIM?
Good question. Unlike Code Companion, which uses a single buffer, Magenta, NVIM separates input and display buffers. This allows for more interactivity in the display, especially when the LLM uses multiple tools simultaneously. Compared to Avante, Magenta, NVIM uses TypeScript and leverages existing SDKs for streaming, leading to better stability and easier extensibility. Plus, the architecture is super clean, making it a breeze to add new features.
So, the architecture is a key differentiator? What makes it so special?
It's based on the Elm architecture, TEA, which makes the code incredibly easy to understand and extend. It also simplifies testing, which is a huge plus, and the rendering uses a VDOM-like system, making the view code very declarative.
That's impressive. What about installation? Is it complicated?
Nope, pretty straightforward. It supports both lazy, NVIM, and Vim plug, and requires Node.js version 20 or higher. You'll need API keys for providers like OpenAI and Anthropic, of course.
And the usage? How intuitive is it?
It uses leader key mappings, mount to toggle the sidebar, MP to paste selections, MB and MF to manage context files, and so on. There's also a really neat inline editing feature using MI. It's all very well documented.
So, the inline editing leverages the chat history for context? That's smart.
Exactly. You build up context in the chat, then use it for precise edits. The display buffer itself isn't directly editable, but you can interact with it using to expand tool requests, review diffs, or remove context. It's all very well thought out.
This sounds incredibly efficient. What about the future of Magenta? NVIM. Any plans for expansion?
Oh yeah, tons of potential. The developer is open to contributions, and there are plans to add more features like model selection and more customization options. The core architecture is designed for easy expansion, so the possibilities are endless.
This is truly a fascinating project. It seems to be addressing some key limitations of existing LLM plugins in a very innovative way. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today. Thanks for tuning in to Tech Bytes and News. Have a great day, and we'll see you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into the fascinating world of poetic illusion, as explored in Elisa Gabbert's New York Times article, Masters of Illusion, The Art of Poetic Reference. It's a really insightful piece.
Absolutely. I'm eager to hear your take on it. The title itself is intriguing. What's the core argument Gabbert presents?
Well, the core argument revolves around the interconnectedness of poetry. Gabbert highlights how understanding one poem often enhances our understanding of others, creating a sort of chain reaction of meaning. It's not just about individual poems, but the entire literary landscape influencing each other.
That's a really interesting point. So, it's less about isolated works and more about a cumulative effect?
Precisely. Gabbert uses Robert Frost's essay, The Prerequisites, as a springboard, where Frost emphasizes the importance of reading poems in relation to each other. It's a process, a journey of discovery, rather than a destination.
I see. So it's like building a web of understanding, where each poem adds a new thread, strengthening the whole structure? That's a beautiful analogy.
Exactly. And she uses some great examples. She discusses how her understanding of G.C. Waldrop's poem was enhanced by her prior reading of Heidegger, highlighting the serendipitous nature of these connections. It's almost like a literary domino effect.
That's fascinating. It seems to suggest that prior knowledge, even seemingly unrelated knowledge, plays a crucial role in interpreting poetry. It's not just about the words on the page, but the reader's entire intellectual baggage.
You're spot on. And she even brings up Charles Wright's experience with Ezra Pound's The Cantos, where a single word, dodici, unlocked a whole new level of comprehension. It emphasizes the role of chance and serendipity in this process. It's not always about deep scholarly analysis. Sometimes, dumb luck can lead to profound insights.
That's a refreshing perspective. It makes poetry seem less intimidating, more accessible, even playful. It's about the journey, the connections, the surprises.
Absolutely. And Gabbert also touches upon the distinction between illusion and intertextuality, drawing on Earl Minor's scholarship. Illusion, she argues, is deliberate, unlike intertextuality, which is more involuntary. It's a subtle but important distinction. It's about the poet's intent.
That's a crucial point. The intentionality of the illusion changes the whole dynamic of interpretation, doesn't it? It adds another layer of complexity.
Exactly. And she ends with a brilliant example. A meme featuring a hissing cat with the text, I myself am hell, which cleverly alludes to Robert Lowell's Skunk Hour and Milton's Paradise Lost. It's a perfect illustration of how illusions can work across different media and time periods. It's incredibly clever.
That's a fantastic example. It really brings the whole concept to life. It shows how illusions can be both subtle and powerful, creating a rich tapestry of meaning for the attentive reader. It's a truly insightful article.
It certainly is. Gabbert's piece beautifully illuminates the intricate and rewarding process of reading poetry, emphasizing the interconnectedness of texts and the role of chance encounters in shaping our understandings. It's a must-read for anyone interested in poetry or literary theory. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this discussion. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into Alfred G. Mayer's fascinating 1897 work on the color and color patterns of moths and butterflies. It's a surprisingly vibrant piece of scientific history.
I'm really intrigued. I know Mayer for his marine biology, but insects? That's a new angle. What's the core of his argument, or rather, his artistic scientific endeavor?
Exactly. He uses these incredibly detailed, almost abstract, color charts of butterfly wings. Think grids filled with meticulously rendered color variations within a single species. It's not just about cataloging. He's trying to uncover mathematical rules governing these patterns, looking for symmetries, linear arrangements of spots, and how color bands develop.
So he's essentially doing data visualization before data visualization was really a thing, right? Using art to explore scientific questions. That's pretty radical for 1897.
Absolutely. And it wasn't just a dry scientific exercise. The article emphasizes his deep personal connection to butterflies, stemming from a solitary childhood spent observing nature. He literally loved the butterflies he raised, you know? It's a beautiful blend of objective scientific inquiry and subjective artistic expression.
That's touching, actually. It makes the whole thing much more human. But did this artistic approach get him into trouble with the scientific community?
Oh, absolutely. Alfred Russel Wallace, a giant in the field, famously criticized Mayer's work in Nature. Wallace argued that the mathematical distortions Mayer used to create his charts made the butterfly wing patterns almost unrecognizable, obscuring important similarities between species. He basically called it a great mistake.
Ouch, a harsh critique. But wasn't there something more to Mayer's work than just the scientific analysis? I mean, those illustrations are stunning, almost psychedelic in their vibrancy.
Precisely. The article suggests that Mayer's work transcends simple observation. His plates are moody, atmospheric, some are swirling and organic, others jagged and fragmented. It's an aesthetic indulgence, an ode to color itself, independent of the purely scientific goal. It's a testament to his passion for the natural world.
It's a fascinating case study in the intersection of art and science, and how even a mistake can reveal something profound about the creator's perspective and the subject itself. It makes you wonder how many other mistakes hold hidden insights.
Exactly. It's a reminder that scientific progress isn't always a linear path. Sometimes, the most unexpected approaches, even those initially deemed flawed, can lead to new understandings and appreciation. And Mayer's work, despite the criticism, remains visually striking and historically significant. Thanks for joining us on Tech Bytes in News. We hope you enjoyed this deep dive into the colorful world of Alfred G. Mayer.
Bye-bye.
Welcome to Tech Bytes in News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the surprisingly complex world of Mario game logos and their color schemes. It's a bit unexpected, but trust me, it's fascinating. Prepare for a colorful adventure.
A colorful adventure indeed. I'm already intrigued. So what's the core question this article is trying to answer? Is it just about logo design, or is there something more?
Exactly. The article tackles the seemingly simple question, what's the most Mario color scheme? But to answer that, it delves into a meticulous analysis of 40 different Mario game logos, each with its unique polygonal color arrangement for the name Mario. It's a surprisingly detailed study.
40 logos? That's dedication. So did they find a single definitive most Mario color scheme? Or is it more nuanced than that?
It's nuanced, to say the least. They looked at the frequency of each color for each letter in Mario, and then at the frequency of complete color sequences. The results are quite surprising. While red is the most common color for the M, green is the most common color overall, appearing 55 times across all logos.
Wow, green takes the lead. I would have guessed red. So what about the complete sequences? Did one emerge as the clear winner?
Not exactly a clear winner, but a few strong contenders. The sequence RGYBG, red, green, yellow, blue, green, appears 5 times, as does RGBYR. But the article also points out that the BGYRG sequence, prominent in games like Super Mario 64, also shows up frequently.
Interesting. So it's not just about the individual letter colors, but the overall sequence as well. It sounds like there's no single most Mario color scheme, but rather a few strong contenders.
Precisely. The article even suggests that the RGYB sequence for the first 4 letters is the most common, appearing in 10 out of 40 logos. Many of these are recent games, suggesting a possible trend.
That's a really interesting observation. It makes you wonder if Nintendo is consciously using this sequence more often now. Perhaps it's become a sort of modern Mario aesthetic.
Exactly. And the article even points out that many of the games with the RGYB sequence feature peach prominently on the box art, suggesting a possible correlation between the color scheme and the inclusion of peach. It's all very speculative, of course, but fun to think about.
It's fascinating how much detail went into this analysis. It's a testament to the power of seemingly trivial observations. I never would have thought to analyze Mario game logos in this way.
Right? It's a fun example of how even seemingly simple things can reveal interesting patterns and trends when you look closely enough. And it makes you appreciate the level of detail that goes into even the seemingly minor aspects of game design.
Absolutely. It's a great reminder that there's often more to things than meets the eye. Thanks for sharing this insightful article.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for another deep dive into the fascinating world of technology and beyond. Goodbye, and have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating piece from Quanta magazine, The Jagged, Monstrous Function That Broke Calculus. It's a story about a mathematical monster that shook the foundations of calculus? Intriguing, right?
Absolutely. Calculus, the bedrock of so much physics and engineering. To think it had such a shaky start. I'm all ears.
Right. For centuries, calculus relied on intuition, not rigorous definitions. The French were happy applying it, but the Germans, especially Weierstrass, wanted to formalize everything. He was quite the character, you know, a late bloomer, spent years teaching penmanship and gymnastics before becoming a mathematical giant.
Penmanship and gymnastics? That's amazing. So what was this monster function all about?
It challenged the core concepts of continuity and differentiability. A continuous function is one you can draw without lifting your pencil. Differentiable means you can draw a tangent line at every point, showing how the function changes. Most mathematicians assumed a continuous function was mostly differentiable, except maybe at a few points.
Makes sense. So Weierstrass's function broke that assumption?
Exactly. His function was continuous everywhere, but nowhere differentiable. It was infinitely jagged like a sawtooth comb. Imagine trying to draw a tangent line on that. It was a complete game changer.
Wow. So the mathematical community's reaction?
Let's just say it wasn't universally celebrated. Poincaré called it an outrage against common sense, and Hermite called it a deplorable evil. Ouch.
Harsh. But why the strong negative reactions?
Because it shattered their intuitive understanding. It showed that calculus couldn't rely solely on geometric intuition. Weierstrass's work forced a shift towards rigorous definitions, using precise mathematical formulas. The epsilon-delta definition of a limit, for example. This led to the field of analysis.
So it wasn't just a theoretical curiosity?
Not at all. It turned out to have practical applications. It's used to model Brownian motion, the random movement of particles, and even uncertainty in decision-making and financial markets. Who would have thought?
It's incredible how something so seemingly abstract can have such real-world implications. It really highlights the power and sometimes unexpected applications of pure mathematics.
Precisely. Weierstrass's monster function, initially met with fear and disdain, ultimately revolutionized calculus and continues to shape mathematics and its applications today, a testament to the power of rigorous thinking and the unexpected beauty of mathematical monsters.
A truly fascinating story. Thanks for sharing this eye-opening insight into the history of mathematics.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for another dose of fascinating tech and science news. Goodbye, everyone.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating technical paper on the impact of extremely low temperatures on 5 nanometers SRAM array size and performance. It's a hot topic, literally and figuratively.
Absolutely. I'm eager to hear this. What are the key takeaways from this research? Is it all about pushing the limits of miniaturization?
Precisely. The paper, published in the IEEE Transactions on Quantum Engineering, explores how operating 5 nanometers FinFET SRAM arrays at cryogenic temperatures, down to 10 Kelvin, affects their size and speed. They found some surprising results.
Surprising how? I'd imagine lower temperatures would generally improve performance, right? Less leakage current, faster transistors.
That's the intuitive expectation, yes. And while reduced leakage current, I less than sub greater than leak, is a factor, The researchers discovered that at extremely low temperatures, the limiting factor for maximum array size isn't leakage, but rather the parasitic effects of the word lines, WLs.
Wordline parasitics? That's unexpected. Could you elaborate? What exactly are those parasitics doing to limit the size?
Sure, think of it like this. At these extreme temperatures, the WL capacitance becomes more significant relative to the transistor behavior. This increased capacitance slows down the switching speed of the SRAM cells, limiting how large an array you can effectively drive before the signal degradation becomes unacceptable. The bit lines, BLs, also play a role, but the WLs are the primary bottleneck.
I see. So even though leakage is reduced, the increased capacitance at low temperatures negates some of the performance gains. That's a really important consideration for designing cryogenic systems.
Exactly. The study also looked at 3 different SRAM cell types, and the findings were consistent across all of them. This highlights the fundamental nature of the limitation imposed by WL parasitics at cryogenic temperatures. It's not just a matter of tweaking a specific design.
Right, this research really emphasizes the need for a holistic approach to cryogenic CMOS design. It's not enough to just focus on individual transistor characteristics. You need to consider the entire array architecture and its parasitic effects. Fascinating.
Absolutely. And the researchers also investigated the impact of threshold voltage, V less than sub greater than TH, engineering on SRAM array optimization at low temperatures. They found that careful tuning of V less than sub greater than TH can help mitigate some of the negative effects of WL parasitics. But it's not a silver bullet.
So it's a complex interplay of factors. This research really changes our understanding of the design trade-offs involved in cryogenic computing. It's not just about smaller is better. It's about understanding the limitations imposed by the interconnect at these extreme temperatures.
Precisely. This paper is a significant contribution to the field, offering valuable insights for researchers and engineers working on extremely low temperature computing. It underscores the importance of considering the entire system, not just individual components, when designing for cryogenic environments. It's a game changer.
Indeed. Thanks for breaking down this complex research for us. It's a great example of how fundamental physics can impact the design of cutting-edge technology. I'm already thinking about the implications for future quantum computing architectures.
My pleasure. And that's a great point. The implications extend far beyond just SRAM. This research has broad implications for the future of cryogenic computing. Thanks for listening to Tech Bytes and News. We'll catch you next time with more exciting developments from the world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Llama.Vim, a Vim plugin offering local LLM-assisted code and text completion. It's pretty exciting, isn't it?
Absolutely. This sounds incredibly useful for boosting productivity. So what's the core functionality?
At its heart, Llama.Vim provides on-the-fly suggestions as you type in Vim's insert mode. You get auto-completion powered by a local LLM, eliminating the need for internet connectivity. Think of it as having a super smart code assistant right inside your editor.
That's a game changer. How does the suggestion mechanism work? Is it just keyword-based, or is it more sophisticated?
It's far more sophisticated. It uses a context window around your cursor, pulling in information from the current file, other open buffers, and even your yanked text. This gives the LLM a much richer understanding of what you're trying to do.
I see. So it's not just looking at the immediate line, but at a broader context. That's smart. How do you control the scope of that context?
You can configure it. The plugin lets you adjust the size of the context window, allowing you to fine-tune the balance between accuracy and performance. It even supports incredibly large contexts, even on less powerful hardware, thanks to clever context reuse techniques.
That's impressive, especially the optimization for low-end hardware. What about accepting suggestions? Is it just a simple tab completion?
It's more nuanced than that. You can accept a suggestion with tab, or just the first line with Shift plus tab. You can also manually toggle suggestions with Control plus F, giving you complete control over the process. Plus, you can control the maximum generation time to prevent excessively long waits.
Nice. So it's highly configurable. What about installation? Does it require a lot of setup?
The installation is relatively straightforward. It supports both Vim plug and Vundle. The real key is setting up the llama.cpp server, which is the engine driving the LLM. You'll need to download and run that separately, choosing a model size based on your VRAM. They provide pre-built binaries, making it easier.
So it relies on llama.cpp. That makes sense. And what about the models themselves? What are the recommendations?
They recommend several models from the Hugging Face collection, specifically those compatible with the GGML format. They provide different sizes, allowing you to choose one that fits your hardware. Larger models offer better performance, but require more VRAM.
Makes sense. So it's a trade-off between performance and resource consumption. Are there any performance metrics displayed?
Yes. The plugin displays performance stats, showing you things like context size, generation time, and the number of tokens processed. This helps you understand how the plugin is performing and identify potential bottlenecks.
That's really helpful for debugging and optimization. Are there any limitations or downsides?
Well, the main limitation is the reliance on llama.cpp and the need for sufficient VRAM. Larger models are slower and need more memory. Also, it's currently Vim specific, although they have a Versus Code extension in the works.
Right, that's a fair point. But overall, it seems like a powerful tool for developers. Thanks for the overview.
My pleasure. It's a really exciting development in local LLM integration for code completion. And remember to check out the GitHub repo for more details and examples. Thanks for listening to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Threlty 8, a major release packed with exciting new features. It's a significant upgrade, folks.
Yeah, I've been following Threlty's progress, and this release sounds huge. What are the key improvements they're highlighting?
The biggest change is the completely revamped component. They've streamlined it, making it more flexible and powerful. Props are now evaluated individually, the attach function is supercharged, automatic disposal is more transparent, and events are aligned with Svelte 5. It's a massive improvement in terms of developer experience.
Wow, individually evaluated props? That's a game changer for performance, right? Less overhead?
Exactly. And the improvements to attach and automatic disposal mean cleaner, more predictable code. Less memory leaks, more stability at that side. It's all about making 3D development on the web smoother, more efficient.
And what about the new additions to @Threlite/extras? They've added a whole bunch of new components, haven't they?
Absolutely. We're talking guest day, several new texture types, use viewport, and more. It's a massive expansion of their component library, giving developers a much wider range of tools to work with. They've really thought about the needs of the community here.
I see. So more tools for building richer, more complex 3D scenes. What about the underlying architecture? Any significant changes there?
Oh yeah, big changes under the hood. They've fully embraced Svelte 5's reactivity model, updating their plugin API to take advantage of it. This should lead to even better performance and integration with Svelte projects.
And web GPU support. That's a huge deal. Is it easy to integrate?
Surprisingly so. They claim it requires minimal changes to existing projects to start using Three.js's new web GPU renderer. They've also provided guidance on using Three.js's new shading language, TSL. This opens up a whole new world of possibilities for performance and visual fidelity. It's a really exciting development.
It sounds like they've really gone all in on performance and developer experience. What about the migration process? Is it painful?
There are breaking changes, so it's not completely backward compatible. But they've provided a detailed migration guide to help developers through the process. And they're encouraging community engagement on Discord for additional support. They're clearly committed to helping users transition smoothly.
That's good to hear. One last thing. What's next for Threlty after this massive release?
They're deprecating the npm create Threlt command and plan to integrate with Svelte's svcli. This will streamline the project creation process. Plus, they're releasing an alpha version of Threlte Studio, a visual editor that lets you tweak values in the browser and have those changes automatically reflected in your code. It's a really exciting step towards more visual development workflows. It's all very impressive.
This Threlty 8 release is definitely a major step forward for web-based 3D development. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the surprisingly complex world of four-function calculators. Who knew such simple devices could be so complicated? It's a wild ride.
I mean, it seems straightforward. Add, subtract, multiply, divide. But this article reveals a whole universe of edge cases and historical quirks. It's like the UI is hell.
Exactly. The author points out that even experienced software engineers underestimate the challenge. They think, piece of cake, a lunch break project. Wrong. The seemingly simple act of pressing buttons triggers a cascade of unexpected behaviors. Think about it. What happens when you hit a number right after pressing equals or vacation? Or if you chain operations without hitting equals in between?
Yeah, the article highlights the need for an input reset flag. If you press a digit after an operation, the input register needs clearing. Otherwise, you get unexpected results. It's all about managing state, right? And that's where it gets tricky.
Precisely. And then there's operator precedence. A simple calculator doesn't follow the usual mathematical rules. It's strictly sequential. So 2 plus 3 times 5 equals 25, not 17. Crazy, right?
Totally. And the implicit equals after an operation. That's a whole other layer of complexity. The author even discusses the ambiguity of negative numbers and how some calculators handle it with a unary suffix notation before the equals sign. It's a mess.
Yeah, that unary operator is a clever hack, but it introduces its own set of inconsistencies. It's a rabbit hole. For example, 10 plus minus 2 might not equal 8, depending on the calculator's logic. It's not intuitive at all.
And the K-constant feature. I never knew about that. It's this hidden mechanism that lets you loop the last operation or use one operand as a constant. It's a fascinating historical footnote, but it adds another layer of complexity to the design. It's like a hidden Easter egg.
Exactly. It's a testament to how seemingly simple devices can have incredibly intricate internal workings. The article even shows examples of older calculators with even more bizarre input schemes. It's mind-boggling.
It really makes you appreciate the seemingly simple elegance of a well-designed user interface. Something that seems so trivial on the surface can be incredibly difficult to get right. It's a lesson in software design.
Absolutely. This article is a great reminder that even the simplest of things can hide surprising complexity. And it's a fun read, too. Thanks for joining us on Tech Bytes and News. We'll see you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Mukul Rathi's fascinating blog post, How I Wrote My Own Proper Programming Language. A deep dive into building the Bolt compiler. It's a really exciting project.
Yeah, I've been looking forward to this. The title alone is intriguing. So what's the core idea behind this blog post series?
Essentially, it's a practical guide to building a full-fledged, concurrent, object-oriented programming language. Not just a toy language with basic arithmetic. He calls it Bolt, and it's designed to be more than just a simple exercise. It's ambitious.
Ambitious is an understatement. So what makes Bolt stand out from other build-your-own-language tutorials? I'm particularly interested in the concurrency aspect.
Right. That's a key differentiator. Most tutorials stick to simple languages. Bolt, however, tackles objects, inheritance, method overriding, concurrency, something rarely covered in such tutorials, and even generics, allowing things like linked list. It's a comprehensive undertaking.
Wow, and it compiles to LLVM, right? That's a big deal. That's used by languages like C, C++, Swift, and Rust.
Exactly. That's a huge accomplishment. Leveraging LLVM gives Bolt access to powerful optimizations already present in established compilers. The author even mentions this post was number 2 on Hacker News.
That's impressive. But why would someone even want to build their own programming language? Seems like a monumental task.
The author argues it's about building better mental models. Learning multiple languages reveals common themes. But creating your own forces you to think critically about language design. It's not just about the fun or the coolness factor, although those are definitely there. It's about deeper understanding.
I see. So it's a journey of learning by doing. He uses a really interesting analogy, comparing the compiler process to a 19th century telegraph operator translating speech into Morse code. Clever.
Absolutely. He breaks down the compiler stages: lexing, parsing, type checking, and translation, using that analogy. It makes the complex process much more accessible. He even talks about the runtime environment, which is like the operator's tools for tapping out the Morse code.
And the different compiler approaches, interpreted versus compiled, and the role of LLVMIR as an intermediary. It's all very well explained. What about the type system? That sounds particularly interesting.
Yes, the type checker is a crucial part. In the analogy, it's like the operator checking grammar. Bolt uses a unique approach with both traditional types and capabilities to handle data races. He even mentions a dissertation exploring this in more detail.
2 type checking phases. That's unusual. I wonder if that adds significant overhead. Perhaps a trade-off for the enhanced safety?
That's a great point. It's definitely a trade-off. The added complexity might impact performance, but the enhanced safety and prevention of data races could be worth it, especially in concurrent programming. It's a fascinating design choice.
So in summary, this blog post series isn't just about building a compiler. It's about gaining a deeper understanding of programming language design, concurrency, and the intricacies of compiler construction. It's a valuable resource for anyone interested in these topics.
Precisely. It's a highly practical and insightful guide, and the author's enthusiasm is infectious. He even shares the challenges he faced, making the whole process feel relatable. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of compiler design. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a little-known Little Snitch feature, a powerful network monitoring tool for macOS. It's all about controlling those sneaky background connections.
Ooh, I'm excited. Little Snitch is a lifesaver for privacy, but I've never heard of this hidden feature. What's the scoop?
So, the author, Jeff Johnson, discovered a clever way to fine-tune Little Snitch rules. He noticed Safari, even in private mode, kept connecting to ssl.gstatic.com, a Google domain, on launch. Annoying, right? Very annoying.
Totally. What was causing it?
It turned out to be the Safari search helper, a separate process. Little Snitch usually groups connections from helper processes with the main app, but this was causing issues. A solution? The via keyword in Little Snitch rules.
Wait. Via? Explain.
Yeah, instead of just blocking the connection from the helper process, you can specify both the helper and the main app using via. Like this. Safari search helper via Safari. This lets you create rules specific to the helper process without affecting the main Safari app. Genius.
That's incredibly precise control. So, he could block ssl.gstatic.com connections from the helper, but allow them from the main Safari app, right? This prevents the silent Google connection attempts without breaking Gmail authentication in the Mail app.
Exactly. It's a workaround for a situation where the default behavior of Little Snitch isn't granular enough. He initially thought it wouldn't work, but objective development confirmed it as a valid technique. Pretty cool, huh?
I see. But isn't this a bit of a hack? Shouldn't Little Snitch handle this automatically? Shouldn't Safari be more transparent about its connections?
That's a valid point. It does seem like a workaround for a design flaw, either in Little Snitch's attribution logic or Safari's handling of background processes. Ideally, Little Snitch should automatically differentiate between the main app and its helpers. Or, Safari should be more upfront about its Google communication. It's a bit disappointing that Safari makes these silent connections, even with search suggestions disabled.
Totally. It highlights the importance of tools like Little Snitch. Even with privacy settings adjusted, apps still try to phone home. This via trick is a powerful tool to regain some control. It's a bit hidden though, so it's great that this article brought it to light.
Absolutely. It's a testament to the power of user-configurable network monitoring. And it shows that even seemingly simple apps can have surprising depths of functionality. This via trick is a great example of how to get the most out of Little Snitch. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into a hidden Little Snitch feature. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating article. Every system is a log. Avoiding coordination in distributed applications. It's all about simplifying the complexities of building resilient distributed applications. A real headache for developers, right?
Absolutely. Building distributed systems is notoriously difficult. You're constantly battling potential failures, concurrency issues, and the sheer complexity of coordinating multiple services. The article highlights this perfectly, doesn't it? It's a real challenge.
Exactly. The article starts by pointing out that we spend way too much time dealing with failover, retries, race conditions, and all sorts of other nightmares, instead of focusing on the core business logic, queues, key value stores, locking services. It's a never-ending list of components that need to work together seamlessly. And often, they don't.
Yeah, and the image illustrating the problems in distributed applications really drives that point home. It's a visual representation of the chaos, isn't it? The core idea presented is revolutionary, treating every system as a log. That's a bold statement.
It is. But the article makes a compelling case. Message queues, databases, even locking services, they all fundamentally operate on logs. Databases, for instance, use write-ahead logs. The article even quotes Pat Helland's famous saying, "The log is the database. Everything else is cache." Brilliant.
I see. So the key is to unify all these disparate logs into a single, unified log. But how does that solve the problems of concurrency and failures? I'm curious to know.
That's where the real magic happens. The article uses a process payment handler as an example. Initially, it shows a naive implementation prone to concurrency issues and failures. Then, it presents a more sophisticated version using locks. But even that has flaws. The core problem is the lack of a single source of truth.
Multiple systems have their own views of the world, leading to inconsistencies. So, the solution is to use a single upstream log, right? I'm following you so far.
Precisely. Every action, every state change gets written to this upstream log. Retries become trivial because the log contains the entire history of the operation. If a step has already been completed, the retry simply skips it. Ingenious!
But what about locking? How does a single log handle distributed locking? Doesn't that still require coordination?
That's a great question. The article cleverly addresses this. Lock acquisition and release are also logged. The lock service simply reads the log to determine lock ownership. This eliminates the need for complex distributed locking mechanisms and their associated problems. It's elegant.
So by unifying everything into a single log, you eliminate the need for coordination between different systems. That's a significant simplification. But isn't this a bit of a radical departure from established practices? Doesn't it violate separation of concerns?
You're right to raise that concern. The article acknowledges that using a single log for every operation isn't practical. It advocates for using this approach strategically, for state that's strictly scoped to a handler or service. It's not about replacing databases entirely, but about creating a robust core for critical operations. It's a targeted approach, not a wholesale replacement.
I see. The article mentions Restate, an open-source project that implements this single log approach. It seems like a practical implementation of this concept. Interesting.
Absolutely. Restate provides an SDK that simplifies the process of interacting with the log, handling retries, and ensuring exactly once semantics. It even supports stateful handlers and virtual objects, further enhancing the robustness of the system. It's a game changer.
This is a really interesting approach. It seems like a powerful way to simplify the development of resilient distributed applications. The article also mentions future work on distributed restate, which will be exciting to follow. I'm looking forward to that.
Indeed. The article concludes by discussing the design of the underlying log itself, hinting at some unique features. It's clear that this is a significant advancement in distributed systems design. Thanks for joining us on Tech Bytes and News. We hope you found this discussion insightful. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating story. A top-secret Cold War spy satellite program called Parquet, which played a pivotal role in maintaining global stability. It's a story of technological innovation under immense pressure.
Wow, a spy satellite I've never heard of. So what was the big problem that Parquet was designed to solve?
Right. In the early 1970s, the Soviet Navy was rapidly expanding, posing a significant threat. The U.S. lacked the global ocean surveillance needed to counter this. The balance of power, teetering on the edge of mad, mutual assured destruction, was at risk.
MAD, right. So how did Parquet address this critical gap? Was it just one satellite?
Not at all. Parquet was a sophisticated system, not just one satellite, but a constellation. It involved multiple satellites working together, launched in groups of 3. A clever design inspired by the 3 fates of Roman mythology. Each satellite was equipped with highly precise, synchronized clocks for accurate geolocation.
3 satellites working together. That's ingenious. How did they achieve such precise geolocation?
By measuring the minuscule differences in the time it took each satellite to receive radar signals from Soviet ships. Triangulation, essentially, but on a global scale and with incredible accuracy. This allowed them to pinpoint the location of Soviet vessels almost instantly.
Incredible. But the article mentions earlier programs, GRAB and POPI. How did those contribute to Parquet's development?
GRAB, or Galactic Radiation and Background Experiment, a clever cover name, was the world's first spy satellite. It was rudimentary compared to Parquet, but it laid the groundwork. POPI improved upon GRAB, but still suffered from slow data processing. Parquet built on these predecessors, addressing their shortcomings with advanced data processing and near real-time intelligence delivery.
So Parquet wasn't just about detecting signals. It was about processing and delivering that information rapidly. How fast are we talking?
Minutes, not hours or days like its predecessors. The goal was to get information from sensor to shooter in minutes, a crucial factor in a world on the brink of nuclear war that required breakthroughs in satellite technology, computer hardware, data processing, and communications.
That's amazing. What kind of technology made this speed possible?
Several things. They used advanced mini-computers with real-time interrupt capabilities, allowing for continuous data processing. They also developed sophisticated software to filter out irrelevant data and highlight signals of interest. And of course, a secure, high-speed communication network was essential.
I see. The article mentions the intercept-to-report interval. That sounds incredibly important.
Absolutely. Captain Collier, the NRO program manager, emphasized that a delay longer than it took to fry an egg was considered a potentially existential vulnerability. The speed of information delivery was paramount for national security.
That's a powerful statement. What about the legacy of Parquet? Did its technology have lasting impact?
Oh, absolutely. Its rapid dissemination model, the ability to deliver intelligence quickly and efficiently, continues to influence modern satellite signals intelligence. Even the Secure Communication Network, TREBA, was used as late as Operation Desert Storm.
That's incredible. It's amazing to think how much this secret program shaped the world, even though most of us never knew it existed.
Exactly. The story of Parquet is a testament to the ingenuity and dedication of the engineers who worked on it, and a reminder of the crucial role technology plays in national security. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating security vulnerability discovered in Subaru's Starlink system. It's a wild ride, folks.
A wild ride indeed. I've heard whispers, but I'm eager to hear the details. What exactly was compromised?
Essentially, a critical vulnerability allowed almost complete access to Subaru vehicles and customer data across the US, Canada, and Japan. Think remote control of vehicles, complete location history, and access to sensitive personal information, all with minimal information.
Minimal information? You're kidding, right? What kind of minimal information are we talking about here?
Just a last name and zip code, an email address, phone number, or even just a license plate number was often enough. Scary, huh?
Absolutely terrifying. So what could an attacker actually do with this level of access?
Oh, pretty much anything. Remotely start, stop, lock, unlock, and track the vehicle in real time. They could even access a year's worth of location data, precise to within 5 meters.
5 meters? Ooh, that's incredibly precise. And what about the personal data?
Yeah, that's the chilling part. Attackers could retrieve full PII, addresses, billing information, though not full credit card numbers, thankfully, emergency contacts, and even vehicle pins. It was a goldmine of sensitive data.
So how did this vulnerability come to light? Was it some sophisticated exploit?
Not exactly. It started with a researcher, Sam Curry, who wanted to hack his mom's new Subaru. He started by auditing the My Subaru app but found nothing exploitable. Everything seemed secure.
Interesting. So he changed his approach?
Exactly. He suspected there might be employee-facing applications with broader access. His friend, Shubham Shah, spotted a clue. The my.subaru.com domain was a name for subarux.com. This led them to discover a Starlink admin portal.
Ah, the classic subdomain enumeration trick. Clever. So what was the vulnerability in the admin portal itself?
They found a password reset endpoint that didn't require a confirmation token. Just send an email, a new password, and boom! Account takeover. They even bypassed 2 FAs by simply removing a client-side UI element.
That's incredibly sloppy. I mean, seriously? No token-based password reset? No robust 2FA implementation?
Yeah, it was shockingly bad. But the real kicker was the data they could access after gaining access. They could search for vehicles using minimal identifying information and gain complete control.
So what happened after they reported the vulnerability?
Subaru patched the system within 24 hours. Thankfully, it seems it wasn't exploited maliciously before the fix. But the implications are huge. The whole system relied on trust. And that trust was completely broken.
It highlights a critical need for better security practices in the connected car industry. This isn't just about convenience. It's about protecting people's safety and privacy.
Absolutely. This case serves as a stark reminder of the potential consequences of inadequate security measures in connected vehicles. Thanks for joining us on Tech Bytes and News. We'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of AMD's Zen 5 architecture, specifically its unique front-end setup and the surprising implications of disabling its op cache. Get ready for some serious tech talk.
I'm pumped. So Zen 5 has this dual fetch and decode cluster setup, right? What's the big deal?
Exactly. Each cluster serves one of the core's 2 SMT threads, reminiscent of the older steamroller architecture. Both can decode up to 8 instructions per cycle with 2 threads, or 4 with 1. But that's where the similarity ends. The key difference is Zen 5's massive 6K entry op cache.
A 6K op cache? That's huge. So the decoders are mostly idle then?
Pretty much. The op cache handles most of the instruction stream. This makes evaluating the decoders tricky, but luckily, there's a way to force them into action. You can disable the op cache by setting a specific bit in a particular MSR register.
Clever. So you did that, right? What did you find?
Yep. With the op cache off, a single thread is limited to 4 IPC, as expected from a 4-wide decoder. But with 2 threads, we hit 8 IPC, utilizing both decode clusters. It's a 2x improvement.
That's impressive. But, isn't this completely unrealistic? I mean, who's going to run Zen 5 with the op cache disabled?
You're absolutely right. It's not a real-world scenario. It's more of a controlled experiment to understand the decoder's capabilities in isolation. Think of it as a stress test, and the results are interesting, especially when compared to older architectures like Excavator.
How so?
Excavator, while also having a clustered decoder, lacks Zen 5's dual fetch paths. This means Zen 5 handles L1 and misses far better, especially with 2 threads active. It's a significant architectural improvement.
Interesting. So what about real-world benchmarks? How did disabling the op cache affect performance in something like Spec CPU 2017?
Big hit in single-threaded mode. A 20.3% drop in integer and 16.8% in floating point. But with SMT, the impact is much smaller, 4.9% and 0.82% respectively. The dual decode clusters really shine in multi-threaded scenarios.
Wow, that's a huge difference between single and multi-threaded performance. So the op cache is crucial for single-threaded performance, but the dual decoders help mitigate the performance loss in multi-threaded workloads?
Precisely. High IPC workloads suffer the most from disabling the op cache, while lower IPC workloads are less affected. Games, for example, showed minimal performance changes with the op cache disabled. They're generally low IPC workloads and don't fully utilize the op cache's high throughput.
So what's the overall takeaway? Is the dual decoder setup a good design choice?
It's a smart design. While a single 4-wide decoder isn't ideal for high IPC workloads, the dual cluster setup excels in multi-threaded scenarios. It's a secondary instruction delivery mechanism, stepping in when the op cache can't keep up. It's all about balancing single-threaded and multi-threaded performance. And Zen 5 does a remarkable job.
It sounds like a really clever engineering solution. Thanks for breaking it down.
My pleasure. And remember, folks, if you enjoyed this deep dive into the intricacies of Zen 5, consider supporting Chips and Cheese on Patreon or PayPal. You can also join our Discord community for more tech discussions. Until next time, goodbye.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.